F1 cos 30.
Very good. Okay. Always remember, if I drop this as a perpendicular, Shreya, please pay attention to this. Okay. If I want, I'm interested in, this is the x-axis. I want the component of F1 along the x-axis. So I drop the perpendicular and I'm interested in this length. Let's call it as OA. Okay. So OA, the length of OA is going to be the component of F1 along x-axis. Okay. So how will you calculate that F1x? It will be F1 into cos 30. It is important that you understand this. Okay. Always find the angle between the force and the axis. Okay. Because sometimes we get confused. What is, whether it is cos 30, sine 30, we get confused. Okay. Always find, this is the force, this is the axis onto which you want to resolve F1. So just sweep cos of that angle. So F1 cos 30, you will get this fellow OA. Okay. What is that cos 30 now again? Root 3 by 2. So this will be root 3 F1 by 2. Okay. Likewise, I want F1 along the y-axis. That means I want the vertical component of F1 along y-axis. Okay. So how do I do that, Shreya?
We take sine 30.
Okay.
Sine 30.
Correct. You can take sine 30, or in other way, what you can do is, this is F1, this is the y-axis. What is the angle between this fellow? Okay. So this is 90 degrees, this is 30, that means this will become 60. Okay. So once again, you take F1, sweep cos of the angle between the axis and F1. Here the angle is 60, so you can say F1 cos 60. Okay, F1 sine 30 and F1 cos 60 both will be the same. So this will be F1 by 2. Are you guys following this?
Yes, sir. Yes, sir.
This will be F1 by 2. So that means now F1's job is over. We have resolved F1 along x-axis, which is OA, and along y-axis, which I can say OB. Likewise, can you now resolve F2 also along x-axis? So it will be this fellow out here. You can say this is OC, and you resolve this fellow along y-axis. That means you drop a perpendicular here again. Okay. And tell me what will be OC and OB or whatever along y-axis.
So I have a doubt.
Go ahead, Ma.
So we know all the forces are acting at 120 degrees, right?
Hmm.
So can't we just write the net force will be 0, because I think we know that.
How do you know that?
I don't know, sir, but I read it somewhere, I guess.
Yesterday, you guys did know how to resolve this along x-axis and y-axis, isn't it? So today I'm teaching you, I'm making it. Yesterday we discussed it in the last 5 minutes. Okay, you have not, I don't know how much you have understood. So today I'm teaching you step by step how this has to be done. What if the three forces are not the same? In this case, because they are the same, they happen to be equal. Net force will be 0. But if I have F1, F2, F3 are different, then you should know how to resolve it. Is it okay? So resolve it. Tell me net what is it on the x-axis, y-axis. Then we will take the resultant of that. All right. Okay. So Chaitri, can you tell me what will be F2 along OX dash?
It's root 3 F2 by 2.
So horizontal component of F2 along x-axis or OX dash, right, is going to be equal to F2 cos 30. But we know that all the three forces are the same, right? So in fact, we can call this fellow as F, this fellow as F, this fellow as F, because everyone is that K capital Q into small q divided by L by root 3. They're all the same. So we will call this as F cos 30. This will be F into root 3 by 2 again. So root 3 F by 2. So this is also root 3 F by 2. This is F by 2, right? So Neha, what is F2 along vertical?
F by 2.
F2 along vertical will act which way?
Along y-axis.
On positive y-axis, isn't it? So
Yes.
F2 along vertical will be once again plus F by 2. Okay. And Chaitri, do we need to resolve this F3?
No, sir.
Yes or no?
No.
No, not required, because F3 is perfectly on the y-axis. So such fellows we will not touch. Okay. So now, Shreya, tell me total, what are the forces which are acting on the positive x-axis?
I mean, I didn't get your question, sir.
So what is the total, what are all the forces which are acting on the positive x-axis now?
Root 3 F by 2 and F by 2. The F1. F1 force.
Okay. See, this F1 is equal to F now. So this is only root 3 F by 2. Root 3 F by 2 along positive x-axis. Likewise, what is the force acting along the negative x-axis?
Again, the same thing. Root 3 F by 2 itself.
All right. What are the forces which are acting on the vertical positive y-axis?
It's F by 2.
Only one? Is it only one?
So,
See, this, I don't know why. Okay. So this fellow, we have resolved it. This, similarly, this fellow also we resolved, no?
yeah, so another F by 2.
That's what, when I say total, you have to tell me two forces are there. Both forces are acting on the vertical, because now two forces are acting means what will be the total of this?
F by 4.
F by 2 plus F by 2 is F by 4, huh?
Sorry, 2F by 4.
Half plus half.
1.
F by 2 plus F by 2 is,
F, sorry.
don't get nervous, okay? So total along vertical y will be F, okay? And this fellow is F once again, okay? And this are equal and opposite. So Chaitri, can you tell me now what is the overall force? Next.
So it will be 0.
0, okay? Because this guy and this guy cancel each other. This is top F, this is bottom F, cancel each other. That means net force is going to be 0. Is it okay? Like Anna mentioned, once you get some experienced, you will know that if you have equal forces, vectors, which are acting about a point, if this is F, this is F, this is F, and the angle between them is 120 degrees. Okay. Through this example, you know, all these three guys will result in a net force of 0. Is it all right? Okay, good. I hope you got this. Shreya, did you understand this?
Yes, sir, I did.
Okay, let's do this numerical. We have a triangle. And we have charges Q, Q, and minus Q. This fellow is minus Q. This fellow is plus Q. And this fellow is plus Q. Okay. I want you guys to find out the total charge or the total force on C. Find net force on C. Once again, you can take, this is an equilateral triangle, means each side is going to be L. Let's see who can do this first.
Sir?
Vaima.
So will it be K Q square by L square?
How did you do that?
So I just found F on C by B, that is FCB, and FCA.
FCB, okay.
And FCA, they both are equal and their magnitude is K Q square. Oh, I think that's... No, I think I'm right, sir.
Okay.
So, which the magnitude is K Q square by L square. And the angle between the two vectors will be 60 degrees. Vertically opposite angles. And then I just used the formula and I found the answer.
Okay. I'll give you some more time. Just recheck it once.
So I got the magnitude as √3 kq square by L square.
What is
Yes,
that?
sir, that's right.
So what is the angle between these two forces?
120.
Understood? Anna?
Yes, sir.
See, this first force is repulsive force, right? This is plus Q. Very good, Shreya. This is plus Q, this is plus Q, repulsive acting in this direction. This is minus Q, and this is plus Q. That means this is going to be an attractive force acting on this side. So if you take this fellow as F1 and F2, I know both of them are equal. Okay, so we can say both of them are equal to F into F and F, okay, KQ square by L square, each of them. Then this angle is going to be the exterior angle. Exterior angle is nothing but the sum of the two interior angles, and or you can tell that this is angle in a straight line 180, this being 60, this is going to be 120. Okay, so we have two equal forces F and F, which are having an angle 120 degrees between them. We can use the parallelogram law of forces. Okay, so Shreya, can you tell how to do that parallelogram law? What is the resultant force?
So it will be F1 plus, under root F square plus F square, 2 F square cos 120.
What is cos 120 again?
Minus half.
So it will be F, right?
3F.
2F square minus F square is how much?
Oh, correct. Wow. Yeah, so F.
It will be F. Okay. So, and what is F for us? F is nothing but K into Q divided by L square, or K Q square by L square. Because here cos 120 happens to be minus half. Minus half means you will get 2F square minus of F square, which will be just under root F square. That means F means K Q square by L square. Chaitri, are we good, ma? Your video is off.
Yeah, so I wasn't able to hear you properly, so I just switched it off. I got it.
You got this, no? So K is nothing but 1 by 4 pi epsilon naught, or you can leave it as K, doesn't matter. Neha, did we get this?
Yes, sir.
Okay, so now you should be comfortable. See, the reason why I'm taking so much time in one particular case is you will understand that parallelogram law when to use. Here also you can use resolving in the horizontal and vertical. Okay, and you can use parallelogram. Both of them are effective means in order to work whenever these vectors are coming into picture. Okay, and once today's class is over, you open your NCERT book or DC Pandey, whatever book you have, try to do more numericals which involves these kind of charges and forces. Okay, try to do some examples. Don't postpone it for later. All right, so good job. I think I have one more interesting question. Let me see. This particular thing, can you please read this, Chaitri?
Coulomb's law is stated in terms of point charges, but it is also valid for spherically symmetric charge distributions as long as the distance is measured from the center of the sphere.
Yeah, because so long what we have been telling is, this is one charge here Q, some other charge Q. So when we are talking about this, we are assuming that this charge is a point charge and we are able to take these distances D. But what if in real world, you don't have point charges now? You will have some sphere. On that sphere, you will be depositing some charge, right? So this Coulomb's law is applicable even though these are not point charges, but they are, real world spheres or, whatever geometries. But you have to take the center to center distance between these objects. So long as you take that, this Coulomb's law, F is equal to Q1, Q2 by D square is applicable. All right, guys. Okay. This is your homework. Can you please, Neha, read this question?
Coulomb's law for electrostatic force between 2-point charges and Newton's law for gravitational force between 2 stationary point masses both have inverse square dependence on the distance between the charges and masses. Compare the strength of these forces by determining the ratio of their magnitudes for an electron and a proton and for 2 protons.
Tell me, what is it that you'll be doing? You read it. By your reading itself, I know you have not understood. You just read the English of it. Chaitri, can you explain?
Yeah, so basically the force is inversely proportional to the distance between both the particles. So we just have to find the strength of electron and proton and 2 protons and compare the strength of the forces.
Then what is he talking about? Newton's law of gravitational force and electrostatic force. He's talking about two things, no?
Yeah, we probably have to take both of those and then
Probably,
compare the
yeah.
ratio.
What do you mean by
We have to take those two.
You have to, isn't it? Because the question is this. Here, Newton fellows says you have two particles, right? Those electron, proton, they have some mass. However small they may be, we don't care, right? But they do have some mass and they are separated by certain distance. Okay, so you have one gravitational force coming into picture. Are you able to understand this? Anna, did you hear what I said, ma?
Yes, sir.
What is it I said? Tell me.
So you said protons and electrons have masses, which comes into the picture during the gravitational, using the gravitational law.
Gravitational law, very good. Okay. Likewise, electron and proton are also charges, positive, negative. That means electrostatic force also will come into picture. So what we are trying to do in this is, you take two charges and one proton, one electron. Their masses we know. Have some distance between them. Any distance L you take. Then you say, as per Newton's law, what is the force of attraction between them? Any mass will have attractive force. Gravitational attractive force. Call that as FG. Then you take both these charges, treat them as charges, and find out the electrostatic force. This is Fe. He wants us to compare Fe with respect to Fg. You understood the question? Okay, so this is what your homework is going to be. Please do that and we can discuss it tomorrow. So basically, we need Fe by Fg for proton and electron. And second thing is, we need Fe by Fg for 2 protons. For convenience sake, take the distance in both the cases to be some common distance L, D, whatever. Okay? This is your homework. All right. Now we come to the concept of electric field, okay? So, Neha, can you please read?
Electric field. What is electric field?
Can you tell me what do you think electric field is?
So the path along which the charges.
Path along which the charges?
Exert force.
So what is electric field? Electric field is a path.
So can I?
Go ahead, ma.
So electric field is the path where electric field lines are represented.
Electric field is the path where electric field lines are represented. No, not very clear. Anna, can you try? Chaitri?
Like the area around which the electric field lines are around.
The area around the electric field lines are around. Okay. None of you have given a satisfactory answer. Let's look at it. Okay. Go ahead, Neha, please read this.
Coulomb's law says F is equal to Q into Q by D square.
Yeah, means K is also there. Don't worry about K.
What happens if Q is removed? Is there anything left?
So what we are telling is I am having some charge Q. Okay. And I'm having another charge Q. So Coulomb's law is telling the force between these fellows is equal to Q by D square. I am assuming that the distance between these fellows is D. Okay, so my question is, okay, I'm removing this charge. I'm taking it and throwing it away. Okay, so is there anything going to be left when Q is not there? Means if there is supposed to be a force, does it mean that it happens only when this Q is there? If this Q is not there, is it that nothing exists? What is your feeling?
So it does exist, sir.
Something exists, right? Okay.
Yes, sir.
Something exists even if this Q is not there. This something exists because of what?
The electric charge of the particle.
Because of this fellow, isn't it? Yes or no?
Yes, sir.
Isn't it? So something is going to exist because of this fellow. Okay. So supposing I put a very small charge here. Okay. Let's say some 1 microcoulomb, some charge Q1 is equal to 1 microcoulomb I put it. Okay. It is going to experience some force. Let that be F1. Now I replace this, and in this point I put a Q2, and that Q2 is going to be 1 coulomb, not 1 microcoulomb. I'm going to put 1 coulomb. That's going to be F2. Okay, what will you say as a comparison between F1 and F2?
F2 is going to be stronger.
F2 is going to be very good. Please follow the discussion. F2 is going to be much stronger than F1. Okay, that's because Q1 is very small, Q2 is larger, 10 to the power of 6 times larger than Q1. Okay, but this Q is the same. Here, this fellow is the same. Now, how do I define whatever we are experiencing? Means whatever this Q1 is experiencing, whatever this Q2 is experiencing. Okay, these guys are experiencing force because of this fellow. He is the central attraction. So if I put Q1 very small force he is experiencing. If I put Q2 very big, Q2 big, he is experiencing greater force. Okay, so how do I characterize this force experienced by them with this fellow in mind? Because he's the hero. Q is the hero here, capital Q.
Sir, can we say the extent to which the electric charge of the capital Q is experienced as the electric field?
Extent to which means what? Because
the distance.
Naida, you're in the right track, Anna. Okay, but extent to which means I'm freezing the distance. I'm going to take only one point. Equal distances d. Okay, don't worry about multiple points spread around it. Just worry about a particular distance d. Whatever distance is there, it's all d only. Okay, so I want to define electric field as a property of Q. Okay, uh, and this is the example I've told you. I put a small charge, I put a big charge. Both of them are experiencing different forces. How do I describe this, whatever we discussed, with Q in picture? Because if, like we discussed yesterday, no, if I have taken one fixed Q, the field lines are going to be constant, isn't it? They are not going to change. Do you agree to this? If I replace this small capital Q with twice or thrice, then the field lines have to become more dense. But so long as I have a fixed capital Q out here around it, right? The field lines are going to be the same. They are not going to change. Do you guys agree to this?
Yes, sir.
So I'm giving you one by one step, because sometimes we just say field, we take it in a very loose way. Is it area? Is it what? We don't really understand. We're spending some time getting to feel it. What do you mean by electric field? What about you, Shreya?
No clue, sir.
No clue. You're not having a clue is bad. Something you should have. Kshetri.
No, so it's like the same, mainly the surroundings until you can like feel the electric charge.
Correct. See, as you go away, the field will be less. Means supposing you take one charge here, it will experience higher force. You put it here, it will experience lower force. That's why I said, don't worry about the distance. You fix the distance. Okay. Then we say, yeah, this Q is exerting a field around this particular distance, around D. Okay. So how do I categorize that as? How do I explain? How do I quantify? What should I say is this electric field? Supposing I say electric field is E, how should I give an expression for that?
Is it force or
Is it
force or
force? Go ahead.
um,
You're very close to it, because see, both F1 and F2 are different forces experienced by different charges, but under the influence of the same Q. Okay, so whatever definition you want to give for the electric field has to be based on these forces only.
Force into charge.
Force into?
Charge, like Q, the
Very
charge.
good, very good. So electric field is going to be based on F, and it is going to be based on Q. Okay. In fact, electric field is nothing but force divided by Q. Are you able to understand? Force divided by C. If I put a small charge, it is experiencing small force. If I put a big charge, it is experiencing a bigger force. That means I can say electric field is nothing but force experienced by unit charge. Are you able to follow this? So when I say Q naught means per charge, force per charge. Okay, so if I put more charge, it is going to experience more force. If I put less charge, it is going to experience less force. So electric field is defined as force experienced per charge. Anna, do you follow this, ma?
Yes, sir.
Okay, can you please read this?
If nothing is left, how come force F comes into existence the moment we bring in Q?
It means
This can be explained by the concept of a field due to Q that exists as long as Q exists. This is called electric field.
so as long as the Q is existing, okay, you have this electric field, and this electric field E is defined as 1 by 4 pi epsilon naught Q by R square. Okay. This is the formula for that. But if you see this, this takes into, this is like 1 by 4 pi epsilon naught is K. Q by R square, right? That means you have taken the second Q is equal to 1. If that second Q is equal to 1, this becomes F, isn't it? Okay, that means it is force experienced by a test charge. I will follow this. And just the expression for electric field E will be equal to K Q by R square. Okay, now couple of questions. Do you think electric field is a vector?
Yes, sir.
Yes, sir.
Okay, electric field, yes, it is a vector. Okay, that is why if you look at these expressions, right, we say E at a distance R. This R means, okay, it is going to be dependent on the distance from the charge. Okay, so electric field at a distance R is equal to 1 by 4 pi epsilon naught Q by R square. If you see here, we are putting a small R cap. Okay, what does this R cap mean? Because this electric field is a vector, no? So
Is it the resultant, sir?
not resultant. It's not resultant because this is Q. You can have this distance R at any point here. This also is R. Okay. This also distance is R, right? This also is R. Okay. So electric field is a vector. How do you then show the vector part of it? So we say, boss, if you are keeping your charge here, okay, the electric field will be in this direction, in the direction of this R cap. R cap, okay, is going to be like this. Electric field be in this direction. Supposing you're putting your charge here, you want to find the electric field at this point, A. Then electric field will be along the displacement. This is your distance or displacement, isn't it? So it will be along this direction. So this R cap, okay, you can say R1 cap, R2 cap, R3 cap. So this actually shows the distance, the direction of your R. Are you able to follow? This R is the magnitude of the distance. Okay. For example, you will say find the electric field at a point A, which is at a distance of 5. Okay, then you will say electric field magnitude is going to be 1 by 4 pi epsilon naught into capital Q divided by R square, means 5 square. Okay, what is the direction? Direction you will say along QA. Okay, so you will say along QA. So this along QA is replaced by 1 by 4 pi epsilon naught Q by phi square into r cap, because this phi is the distance or displacement direction. So you say along this direction, electric field is going to act. Are you following this?
So can we just define it as unit vector along r direction?
See, unit vector means you don't want that magnitude of vector coming into picture. So along OA, when we say that, that is going to give you the direction, isn't it? R cap is actually unit vector. R cap means unit vector along R. Okay, this unit vector along R means what? This direction OA. Are you following this, guys?
Yes, sir.
Because OA has a direction. OA will be, for example, this is 30 degrees from x-axis, minus 30 from x-axis. This is OB. OB will be 45 degrees from x-axis. Some direction will be there. So when I say along OA or along OB, that will help us to find out what is the direction of the electric field. Okay, so instead of giving that 30 degrees, 40 degrees, 45 degrees, we simplify it by giving this r cap as the direction vector. Okay. All right. Chaitri, go ahead and read this.
The electric field. Definition of the electric field. E is equal to F by Q0. SI unit is Newton per Coulomb.
Yeah, because just as we mentioned, force experienced by a unit charge. Okay, whether it is Q is equal to 1 microcoulomb, Q1, Q2 is equal to 1 coulomb, doesn't matter. This is going to experience a less force. This is going to experience a greater force. So if that happens to be Q is equal to 1, some unit force or a test charge, what is the force it is going to experience? E is equal to F by Q. This will be the definition of electric field. So this F is Newton, this Q is coulombs. Newton per coulomb will be the units of electric field. Shreya, are you following, ma?
Yes, sir.
Please make a note of this. Go ahead and complete this, Chaitri.
Here, Q0 is a test charge. It serves to allow the electric force to be measured, but it is not large enough to create a significant force on any other charges. If Q0 is equal to 1, we get E is equal to F, implying that electric field is a force by charge.
Force by charge means per charge, isn't it? Unit charge. Okay. Anna, do you understand this?
Yes, sir.
Okay, good. Please make a note of this. So from this, guys, if I give you the force between two charges, okay, this is Q and this is 1 coulomb or something, okay? I'm giving you the force. If I say calculate the electric field due to capital Q, is it possible for you to do it?
Yes, sir.
right? How do you do that, Hannah? Can you tell me?
And so we just put it in the formula. A q e vector is equal to vector f by q naught. So we
Yes.
have q naught as 1 coulomb, and the force is given.
Because the force is given when you are able to calculate the force, right? So supposing that force is coming as some 2 Newton, right? And this instead of 1 coulomb, now I'll just change it to 2 coulombs. Just take this as 2 coulombs, okay? Then how will you do that?
So it'll be 2 Newton by 2 coulomb, right?
Very good, very good. That's all, okay? Because we are telling F is equal to 2 Newton, okay? So E is going to be force per charge, okay? So I am experiencing a force of 2 Newton when I am 2 coulombs out here, right? That means electric field is nothing but 1 Newton per coulomb. Okay, so this electric field is because of this fellow Q out here. Okay, now I will ask another question. Supposing at the same distance, I am going to put a charge of 0.1 coulomb. What will be the force it is going to experience? My question is, what is the force that a charge 0.1 coulomb will experience when placed at the same distance in presence of Q?
It's 0.1 because we already know the electric field is 1.
Very good. So you know the electric field is already 1 Newton per coulomb. Therefore, what will be the force experienced? Okay, so you'll say array E is nothing but F by Q ray. So F will be equal to electric field into Q. Electric field here is nothing but 1 Newton per coulomb. And what is the charge that you are placing? Small charge of 0.1 coulomb. Therefore, it is going to experience a force of 0.1 Newton. Are you able to understand this, guys? Okay, so we are using the formula E is equal to F by Q, and we are substituting the value of E is equal to 1. We are finding out F for a Q of 0.1. Therefore, F is equal to 1 into 0.1 Newton. So in the case 1, we have calculated E given F. Okay, in case 2, we have been able to calculate F given E. Did you follow this, guys?
Yes, sir.
All right. Please let me know if you have any queries. We can do it. All right, Shreya, can you please read this?
Let's discuss a little more about electric field. Though E is defined as F by Q, it is not dependent on Q. It is dependent on Q, capital Q, by.
Go ahead.
Because Q is a test charge. That's why it is not dependent on it.
Yeah. So what we are trying to tell you now, what we are trying to tell is, here I have a magnet, right? I am trying to tell you the strength of the magnet. Okay, means I want to define, the property of this I want to define the magnetic field around the magnet as a property of this fellow. He is the hero here. Likewise, when I'm talking about the charge Q, I want to define the electric field, right, as a property of this hero. He's the hero here. Okay. Yes. If I put a strong magnet in the vicinity of this magnet, the force between them will be high. If I put a G12 magnet in the vicinity of this magnet, the force experienced will be low. Doesn't matter, okay? Because the overall force is going to be dependent on the strength of this fellow as well as the strength of this fellow, okay? Similarly, if I have different charges, if I put some charge Q1, some charge Q2, the force experienced by them will, be different. But we want to make the entire experience as the property of this fellow Q. Okay, thereby we say that, okay, even though the formula is E is equal to F by Q, okay, the hero here, the central discussion here is around Q. Okay, the field is because of Q. That's what we we understand. Okay, so we have already discussed this. Electric field is a scalar or a vector. The answer is it is a vector. And what does this depend upon means? This depends upon the the distance vector or the displacement vector. In which direction we are placing the second charge. Okay, so based on that, E is going to be dependent. And one more thing, apart from capital Q, what else does electric field depend on? Any other factors are there?
Force?
That anyway.
The distance between the...
That also is anyway there. Because KQ by R square. So we know Q is going to come into picture. R is going to come into picture. Anything else is there?
The medium.
The medium.
Medium, very good. Because we are saying 1 by 4 pi epsilon naught. This is true only if it is air. What if the charge is immersed in some liquid or oil, right? Obviously, the permittivity of the medium is going to come into picture. Okay, so this electric field will depend on the charge Q, will depend on the distance. It will also depend on the medium in which you are measuring, you're placing the charge Q. Okay, just take a minute or two, make a note of these things which we have discussed. Neha, are we good at this?
Yes, sir.
Okay. So F is along E if Q is positive, F is against E if Q is negative. Okay. Now the question is, how can I get a parallel field like this? Okay, so if supposing I have a plate, and in this plate I am depositing positive charge. Okay, and I take another plate, similar plate, and I deposit negative charge. Okay, then the field that will be established between these two plates, plate 1 and plate 2, will be a parallel field. In fact, this is what happens in a capacitor. Capacitor is, of course, capacitor comes in different shapes, but we can think of a capacitor as two plates which is separated by some distance. And both these plates are having different charges. One is plus Q and the other one is minus Q. Okay, so whatever is the field that is going to be established between these two plates, that will be a parallel field. If you take only one charge or a sphere, positive or negative, then you will have electric field in this way. So electric field will depend on the geometry of it. Are we good, guys?
Yes, sir.
A lot of interesting questions come when you start learning these concepts. I'll see if I can do some good numericals. So we have discussed this a little more about the field lines. They point to the direction of the field vector, electric field vector. So the line, no, it follows the field. It starts at positive charge or at infinity. It ends at negative charge or infinity, okay? Are more dense when the field is stronger. So whenever you have a positive charge, it starts at the positive charge and ends at infinity. Okay, that means these lines will go till infinity. If you have a charge, means you can perceive it at infinity also. Okay, it may be a very, very small charge, doesn't matter. And if you have a negative charge, it will start at infinity and it will terminate at the negative charge. This is the direction of E. And more dense when the field is stronger. So if I have, instead of one positive charge, if I have 3 positive charges, then I have to draw more lines. Means more density. I should represent that stronger electric field with more density of lines. Okay. I mean, we have already discussed this in many contexts, but they're kind of summarizing them in one slide. So once again, if you look at these two figures, they reiterate whatever we have discussed. This is plus Q. So it start from the charge goes towards infinity. This is the electric field lines. Okay. Supposing you're taking this as minus 2Q, means magnitude wise it is double. Okay. So because it is minus, they start at infinity and terminate at the charge. And because the magnitude is 2 times, we have shown that number of lines are more. Here you can say 1, 2, 3, 4, 5, 6, 7, 8. Here you must have 16 lines. That 16 lines indicate that the field here is twice the field here. Are we good, guys?
Yes, sir.
And these kind of diagrams we have discussed in the beginning. So plus Q minus Q, this is the electric field. 2Q minus Q, density plus 2Q means away, more lines, minus Q, start at it, terminate at it. Okay, and both positive or both negative means they will have this shape. Both positive, arrow will be away, both negative, arrow will be inwards. You have made some notes around this earlier itself, right?
Yes, sir.
All right. This we understood. This one is important. Okay. Now, can someone explain what we are trying to do here? Anna, can you try this out?
So we are dealing with an electric field that is at point P. And the force on Q2 by the electric field at point P is E2.
No. What you're trying to say is you have a point P here, right? and you are trying to find out net electric field at a point. Okay, because of Q1 and Q2, means you are having a system of charges. Are you following this?
Yes, sir.
So you are having two charges, minus Q, you are having another charge plus Q, minus Q1 and plus Q2. And these guys will have their own, electric fields around it, isn't it? So you, in the vicinity of Q1 and Q2, you have taken some point P. P is a random point. And you want to calculate, what is the electric field at point P? The question is that. Okay. So the question is, what is the electric field at a point P where system of charges, multiple charges. When I say system of charges, more than one charge is present. Are you able to follow this, guys?
Yes, sir.
Okay. So we will take some simple example. Okay. Let's say I have one charge here plus Q. And let's say here I have another charge here minus Q. Okay. And I want, so I will take some point, random point here, P. Okay. So if I'm interested in finding the electric field at P. Okay. How do I do that? Okay. Can you tell me how? Can you guess? And this can be different also. This can be Q1, this can be Q2. It need not be the same.
So do we first find the force? Oh.
Yes, you're right. Don't be confident. Go ahead, tell me.
Yes, sir. So we find the force where using the formula E into Q.
Hold on. This point P is there. No, here I have not put any charge. It is just a point. At that point P, I want to calculate E, electric field.
We can use E is equal to K into Q divided by the distance square.
Distance square. Okay. So first is, that means you need to define the distance. You need to define where P is. Anna, please pay attention, ma. Please be with me. Okay, so what we need to do, you have to define this point. Where is this P? So I will say, this is some distance R1 and this is some distance R2. It may not be the same. Okay, so go ahead, Chaitri. What were you saying?
So electric field, let's say like if we take Q1.
Okay.
Then it will be,
you say Q1, you say Q2. So tell me, go ahead.
the electric field will be Q1 into K divided by R1 square.
Okay, but what about this Q2 fellow?
So do we have to take it together then, sir?
That's what I'm saying. How do we do that?
So Q1 into Q2.
No.
Do we just add the total electric field together?
No. You don't add it up. Neha, go ahead.
So do we resolve them considering them as vectors?
Resolve them considering them of vectors means what is the underlying principle you want to do?
Superimposition.
Very good. Okay, so both of you, Chaitri and Neha, you tried it. Okay, what we are doing is If I didn't give this fellow, this is not there. What would you do? Hey, very easy, sir. You have given me Q2, Q1, and you have given me a point. You have given the distance. I can find the electric field at P. How will you do, sir? It is here. This is the point P. Okay, electric field is going to be in this, whatever the distance, the displacement vector is there. So I will have an electric field here, E. I call this E1. Hey, what is the value of E1? As Chaitri mentioned, E1 is equal to K into Q1 divided by this distance, R1 square. What is the direction in which it will be along R1? Anna, are we good, ma?
Yes, sir.
Okay, then now comes array, but this is not Q1 alone, Q2 is also there. Okay, see, we did force between two charges using superposition principle. Let us do the same thing here. Now, forget this fellow. Q1, it doesn't exist. Let's only take Q2. So at P, what is the electric field because of Q2? That can be calculated. Again, you have P, you have this fellow Q2, it is negative. That means the electric field will be in this direction. And what is the value of it? E2 is equal to K into Q2 divided by whatever this distance is. This distance, let's take it as R2. So we'll say R2 square. Which direction this fellow will act? It will act along R2. Along R2 means along this direction. Okay, that means you have E1, you have E2, both these are vectors, right? Now you will find the net electric field using the vector concepts again. Are you able to understand? So you'll say this is P, E1 was in this direction and E2 is in this direction. Through geometry, you should be able to calculate the angle between them. Those will be specified. And then you use the parallelogram law and find the E net between E1 and E2. You add them up you find the vectorial addition of E1 and E2, just like you found the forces. Are you able to follow this, guys? Okay, so basically what we are discussing here is, in order to find the electric field at a particular point in a system of charges, we use the principle of superposition. Okay, you forget Q2, you consider Q1 alone, and at this point P, Q1 means the field will start and terminate at that point. That's why you have E1 along this. Okay, PQ1, if I can say that. Okay, and if you look at, because of you forget Q1, you take only Q2, you will say that at P, the field, this is plus. That means this is going to be this in this direction. Okay, because here you'll always put a test positive charge. So wherever you want to find the electric field, you will put a test positive charge. It's like a dummy charge, Q0, but Q0 is going to be plus. And then you will say, array, in which direction this Q0 fellow will be pulled or pushed. So if this is plus, this is minus, that means he's going to experience a force in this direction. That will give the direction of electric field. If this is plus, he is, because of plus, this fellow will experience a electric field this side. So I'll have E1, E2. Then both E1 and E2, like vectors, I can add them up and I can get E net. Are you able to follow this, guys?
Yes, sir.
Okay, please make a note of this. This is also very important. Do let me know once you made a note. The diameter is 60 centimeters. And the sphere carries a charge of 500 microcoulomb. Okay, so we have to do two things. Find the electric field intensity at a distance of 100 centimeters from the center of the sphere. Electric field intensity means electric field only. And at the surface of the sphere. Okay, so the question here is, see, this sphere is 60 centimeters. Okay, that means this diameter, this radius is 30 centimeters. Okay, but I have to find electric field at a point P, which is 100 centimeters from O. Okay, so when I say electric field E is equal to KQ by R square, what should be the distance R? That's the question. What are you guys going to take R as?
It should be 100 centimeters, sir.
Do you agree to that, Neha? Or should you say it is 100 minus 30, 70 you should take?
No, so it should be 100 itself.
Very good. Okay. So please remember, irrespective of the diameter of the sphere, okay? So you may have a sphere this big, and on this sphere you may have some charge. So the diameter of the sphere, you don't worry, you collapse it and you say that 500 microcoulomb is acting at the center of the sphere. That is what we should consider. Okay, the entire charge is concentrated out here. Okay, that means you're collapsing the dimension of the sphere. Kitna bhi bada ho, let it be like a basketball, football, doesn't matter. You collapse it and take it as a point charge. So as far as the distance, when this R is concerned, you take from the center of the, the sphere. Okay, so yes, R has to be 100 centimeters. Calculate that and tell me, please.
Sir, is it 5 into 10 power 7?
No, ma. Some small mistake you've done. So let me work it out along with you. E is equal to 9 into 10 raised to 9, 500 microcoulombs, 500 into 10 to the power of minus 6, correct? Divided by 100 centimeters. 100 centimeters means how many meters?
1 meter.
So it will be 9 into 5. This is 10 raised to 2. 9 plus 2 is 11. 11 minus 6 is 5. Where did you go wrong, Anna?
I don't know, for the denominator, I wrote 100 square, but in the next line, I wrote 9 for some reason.
Don't do such mistakes, okay? So it should be 4.5 into 10 raised to 6 Newton per Coulomb. So this is the first part. So, Shreya, are we good with this, ma?
Yes, sir.
We are just converting the R always into meters because they are dealing with SI units. Point number one. Point number two, R has to be center to center irrespective of the dimension of the sphere. Now, for the second part, that is, you forget about point P. What if I want to measure electric field at the surface of the sphere? Means here, anywhere here. Okay, because the charges are here. So what should we do? Is electric field 0?
No, sir.
So what should you take R as?
30 centimeters.
30.
Very good. Because as we mentioned, this charge which is there, you consider it as a point charge. Means this is equivalent to, right? 500 microcoulomb is concentrated here, like the nucleus. And you are telling me, find the electric field here, which is at a distance of the radius, isn't it? So here you take R as the radius of the circle. So R becomes 15 centimeters. Okay. So this
No,
charge.
sir, R will be 30. Diameter is 60.
Diameter is 60, yeah.
Yes, sir.
My bad. I somehow by mistake I wrote phi is equal to 30. Phi is for diameter. No, R is equal to 30. Yeah, diameter is 60, so R is equal to 30. Thank you. So E will be equal to 9 into 10 raised to 9 into Q is 500 into 10 raised to minus 6 divided by 30 into 10 raised to minus 2 whole square. What are you getting this as? Chaitri has already chatted some answer.
Is it 5 into 10 to the power 7?
5 into 10 raised to 7, huh? Correct.
Yes, sir.
This is going to be 5 into 10 raised to 7. Always remember the unit Newton per Coulomb. Neha, are we good?
Yes, sir.
You're still calculating?
Yes, sir.
Do it off fast. Anna, are we good? Chaitri, of your answer is correct. Good
Yes,
job.
sir.
The application of these concepts, the questions are humongous. Variety of questions you'll get. For all competitive exams, these concepts are very important. Okay, I'm moving ahead. Please make a note of this question. 2 point charges plus 16 microcoulomb and minus 9 microcoulomb are placed 8 centimeters apart in air. Determine the position of the point where resultant electric field is 0. Please take a few minutes, do it by yourself, then we'll discuss.